Okay, this is the last module for Chapter 4, Module 13, and it is Perceptual Organization and Constructing Our View of the World. I think you're really going to like this module. This module deals with a lot of optical illusions, which students usually love looking at, but it's going to also tell us, so far we've talked about sensations in this chapter, your 5 different senses. And if you remember from the beginning of this chapter, I said how sensations were just where the physical stimulus would hit your senses. And then it travels up to your brain. In your brain is where that perception happens, where you actually see a person, where you actually taste a food, you know what you're eating, you hear a song you like, you touch something hot. That's your perception that it is occurring, other than just the sensation, the physical stimulus hitting your senses. If that information does not travel to your brain, there is no perception of it. You aren't even aware that it's there. So that is what Module 13 is going to talk about. And we have 3 questions that we're going to answer. And these questions are somewhat long and in depth. So the first question is, what principles underlie our organization of the visual world and allow us to make sense of our environment? So with this question, we're going to talk about, we have these Gestalt principles that are in place that help us perceive something that doesn't necessarily make sense. The second question is, how are we able to perceive the world in 3 dimensions when our retinas are capable of sensing only 2-dimensional images? So with this one, how is it that our brain comes into play? We see things in 3 dimensions, right? I see people standing in front of me, and that's a 3-dimensional world. However, my retina is only seeing it in a 2-dimension. So we know our brain is involved in overriding that and understanding what we see. The third question is, what clues do the visual illusions give us about our understanding of general perceptual mechanisms? Okay, so let's start out just overview perception, what we mean by this term perception. And you can see there's a light bulb going off, right? We have this piece of crumbled paper and we don't know what it is, and then our brain perceives it as something. So definition for perception, it is a constructive process by which we go beyond the stimulus itself and we attempt to construct a meaningful situation. We take it just from the stimulus and it means something to us. I want to talk about these Gestalt laws of organization. This is going to be that first question that we had that said, what principles underlie our organization of the visual world and allow us to make sense of our environment? We have these Gestalt laws that are in place. So the Gestalt laws of organization is a series of classic principles that we have in psychology that describe how we organize bits and pieces of information into meaningful wholes. The word Gestalt means that the whole is greater than the sum of its parts. That's what this word Gestalt means. The whole is greater than the sum of its parts. And this came about in the early 1900s. And so 2 of these Gestalt laws, one is closure, and that is where we usually group elements to form enclosed or complete figures rather than open ones. So if you've ever done a connect the dots, right? You may be able to tell what the object is before you even connected the dots. Your brain goes ahead and encloses that. even though there may be pieces missing. Sometimes we do that with words. You may have seen those emails go around or those memes where it was just, the words were spelled incorrectly, but if the first and last letter of the word were in place correctly, then you were able to read the word. Our brain goes ahead and encloses that. That's closure. We also have proximity, and that is where we perceive elements that are closer together as being grouped together, as opposed to not being part of the group. So this is figure 1. This is on page 118. And this shows you that we may shift back and forth between different views of the same figure. So in A, you either see a white face or you see two side profiles of two individuals. So sometimes, like the white vase, I've seen this a million times, but the white vase pops out to me first. But I immediately also see the two profiles, the sideways profiles of those individuals. And my eyes will go back and forth between seeing the two. Now, in letter B, the shaded portion of the figure, and this figure is called a Necker cube, that can appear to be either the front or the back of the cube. So you see how that's working. It can either, now for me, I definitely see the back of the cube first. However, now my eye is switching it and I see the front of the cube. You probably see the back of the cube first. But then if you really kind of relax your eyes, the whole thing switches and the green portion is now the top of the cube or the front part of the cube. Let's talk about two more laws of organization that Gestalt has. The first law, the third, actually, I should say, since we already talked about the two, which were closure and proximity. The next one is similarity. This is where elements that are similar in appearance are perceived as being grouped together. If I have a column of oranges, then a column of lemons, and a column of oranges, and a column of lemons, I am more likely to see them as columns than I would as rows, because they all are very similar. I would be less likely to say, I see a row of orange, lemon, orange, lemon, orange, lemon. And then I see a second row of orange, lemon, orange, lemon, orange, lemon, and so on and so forth. My brain will actually put the similar items together, and I see columns of oranges and columns of rows. Now, a fourth Gestalt principle is simplicity. This is when we observe a pattern, we perceive it in the most basic, straightforward manner that we can. We don't think about it too much. If you think about the Olympics, right, there are 5 rings in the Olympic symbol. We see that as 5 rings. We don't see all the separate pieces that go with those 5 rings. And that could probably be 25 different objects if we broke them all up. No, our mind just sees it in the simplest way possible. So figure 2 is going to show you that, and that's at the top of page 119. Here we have all 4 of them, actually. Here we have closure in letter A. We see that as a triangle. We don't see that as 3 separate red kinds of figures. We see it as a triangle. Our mind just automatically closes in those spaces. Proximity. We see that as 2 dots, then 2 dots, then 2 dots, then 2 dots. We don't see it as 1 dot, then 3 dots, then 4 dots, then 2 dots. We just see it as 2 dots. Our brain will automatically put that together. With similarity, again, with this one, this is the opposite of what I just said with our oranges and lemons. You're more likely to say, I see rows of circles, and then a row of squares, and then a row of circles, and then a row of squares, and so on. I would be less likely to say, I see a column of circle, square, circle, square, circle, square, circle, square. And then I see a second column of circle, square, circle, square, circle, square, circle, square. No, our brain will just automatically put the similar objects together. And then with simplicity, the way I see this is I see a diamond with 2 end anchor lines. I could easily break this up into, here is one line, here's another line, then we have 4 lines, and then another line and another line. I could count it as 1, 2, 3, 4, 5, 6, 7, 8. I'm less likely to say I see 8 lines. My brain automatically sees it in the simplest way possible. I see a diamond, and it's anchored by 2 lines. So those are your 4 Gestalt principles: closure, proximity, similarity, and simplicity. All right, the next thing that I want to talk about is top-down and bottom-up processing. Top-down and bottom-up. First off, top-down processing. Top-down processing means that you have prior experience in noticing something, right? When I look at my computer screen, I know it's a computer screen because I have lots of experience with a computer screen, right? So it's a higher level knowledge and experience, expectations, and motivations. However, if I did not know this was a computer screen, I would have to look at it at its most basic form and then build my way up. So we refer to that as bottom-up processing. Something that we are not familiar with. We break it down to its most basic parts and then kind of put it all together as a whole. So top-down processing is you see everything together as a whole because you have prior experience with that. Bottom-up processing is where you don't have prior experience. And so you got to take its most basic forms and then put it together. So this figure will show you, this is figure 3 on page 119. This is bottom-up versus top-down. Most of you can see the figure of the dogs in this photo, right? So there is 1 dog, 2 dogs, 3 dogs, 4, 5, 6, 7, 8 different dogs in this picture. And I see that because I have prior knowledge of what a Dalmatian or what a dog looks like. If you've never seen a dog before, you would have no idea what this is. You would just see a lot of random black dots. There seem to be some lines put together, but you wouldn't really know what that is. So at first, it may be difficult to look at this. But however, once you look at it, for a little bit longer, you see all the different dogs in that photo. We see the same one in this figure. This is on page 120 in your textbook. And this talks about how the power of context is shown in this figure. So the B and the 13 are identical to each other. However, the top row is letters and the bottom row is numbers. So even though the B and the 13 look exactly alike, it's the context. These are letters, so I'm more likely to see this as a B. These are numbers. I'm more likely to see this as a 13. So context is very important when we're looking at something like that. Now, the next slide that we're going to look at here, this is going to explain that second question that we had at the beginning of Module 13. And if I go back and I try to find those questions, there it is. The second question is, how are we able to perceive the world in 3 dimensions when our retinas are capable of sensing only 2-dimensional images? So how is it that we're able to do that? So we're going to talk about depth perception, translating 2-dimensional objects into 3-dimensional objects. So let's talk about depth perception first. And this basic definition for depth perception. It is the ability to view the world in 3 dimensions and also perceive distance. Our ability to perceive the world in 3 dimensions and also perceive distance. That's what we mean by depth perception. Now, what plays along with depth perception is your 2 eyes play into that. And we have what's called binocular disparity. Binocular disparity is the difference in images that are seen by the left eye and also the right eye. The difference between those 2 images in the 2 eyes provides us with a way of determining distance. And that's what kind of helps us go along with that. We have some information that comes into our left eye and some information that comes into our right eye. The combination of the 2 helps us perceive that distance. Now, further talking about this, translating 2-dimensional objects into 3-dimensional objects. We have monocular cues. These permit humans to obtain a sense of depth and distance with just 1 eye, right? Mono meaning 2. We just said binocular meaning 2, or monocular meaning 1, excuse me. We just talked about binocular meaning 2 different eyes. The monocular cue, mono meaning 1, it permits us to obtain a sense of depth and distance whenever we use just 1 eye. Now, motion parallax. This is a change in position of the object on the retina, which allows the perception of movement. Motion parallax is when that object changes position on our retina, we also perceive it as moving, or it has moved. When we talk about relative size, if 2 objects are the same size, the object that makes a smaller image on the retina is seen as farther away. So we could have 2 objects that are the exact same size. However, one of those may make a smaller image on our retina. And if that is the case, it is seen as farther away. So here again, we are talking about distance. If we think about texture gradient, it is the details of things that are far away. The details of things that are far away, they are less distinct. When something is up close, it is more distinct. We're able to tell the details in the texture of that. But when it's farther away, we may not be able to tell the details. We also have what is called linear perspective. This is where objects in the distance appear to converge. The farther away objects are from you, the more they become together, right? That's what convergence means. They converge together. However, if they're up close, you can tell that they're not together. That's the linear perspective. Perceptual constancy. So whenever you think about the word constancy, you think about the word constant. Something that is constant is always there. All right? So think about what we mean by perceptual constancy. It is our understanding that physical objects are unvarying and consistent, even though the sensory input we get may be different. We perceive it as the same. It remains constant, even though that sensory input may be different. So what perceptual constancy does, it is that it allows you to view objects as having an unchanging size, unchanging shape, color, and brightness, even if the image on our retina changes. So just like we talked about previously with the information on our retina changing, the same thing happens here with perceptual constancy. We talked about relative size, right? That if the object on our retina is farther away or is smaller, then we see it as farther away. With perceptual constancy, even though the image may be different on our retina, we do not see it as different. It remains constant to us. So the next thing to talk about is movement, and specifically motion. So we have various cues that tell us about this perception of motion. One of those is the movement of an object across our retina is perceived relative to some sort of stable background. So if you hold your hand out in front of you and you pick up a pen and you move that pen across your hand, right? We see that because the background remains constant. The background is stable. It is not moving. Second thing, if a stimulus is increasing in size, filling more of the visual field, we assume that stimulus is approaching us. So if you look at someone who is across the street and down the block, they seem smaller. But the closer they get to us, they are filling more of our perceptual field, and then we see them as approaching us, right? That's that motion that we see them, right? Same with a car. You look both ways before you cross the street. As the car is approaching you, it's filling more of your perceptual field, and therefore you perceive it as getting closer to you, and you're not going to cross the street. The third thing that we do when we perceive motion is we factor information about our own head and eye movements. Now, what about when something appears to be moving, but it's really not? We call that apparent movement. The perception that a stationary object is actually moving. This occurs when different areas of the retina are quickly stimulated. So when you go to Times Square and you see the tickers going around the buildings, right? Whether it would be the New York Stock Exchange ticker or the news ticker going around the ABC building in Times Square, that is not actually moving. What is happening is light bulbs are just going on and off at different times. However, it appears that that news strip is moving around the building, right? That's apparent motion. The same way that if you're driving down the highway and you come to a construction zone and you see these arrows moving, telling you to get into the other lane. The arrows themselves are not moving. Again, it's just that light bulbs are coming off and on at different times. So it gives this apparent movement. So what happens with illusions, right? An illusion is that you appear to see something that's not really there. That's what we mean by illusion. So a visual illusion is a physical stimulus that consistently produces errors in perception. Physical stimulus that consistently produces errors in perception. Most of the explanations that we have for visual illusions concentrate on either the physical operation of your eye or your misinterpretation of the visual stimulus. That's what plays into us seeing this visual illusion. It's either the physical operation of the eye or the misinterpretation of the physical stimulus. Culture also plays a role here. Your cultural expectations about what you are expect to see definitely plays a role. And we're going to see this in the next couple of slides. So this is figure 5. This is at the top of page 124, right? And in letter A at the bottom, it says, in building the Parthenon, the Greeks constructed an architectural wonder that looks perfectly straight with right angles at every corner. So they pictured it and it looks perfectly straight. However, if you look at B, if it had been built with completely true right angles, it would have looked like it does there. So in order to compensate for this illusion, the Parthenon was disguised or designed to have a slight upward curvature, as shown in C. Right? So again, the Greeks constructed the Parthenon with right angles at every corner. However, if that had been built with completely truly right angles, it would have looked the way it does. However, to compensate for this, the Parthenon was designed to have a slight upward curvature so that you see it as you do in letter C. Now, we see the same thing in figure 6, and this is at the bottom of page 124. This is actually called the Mueller-Lyer illusion. So in letter A, these lines are the exact same size. If you take a ruler out and you measure them, they are the exact same size. However, because of the lines on the top and the bottom, they look different. We also see this, right? They also see this in the sense that the line on the left, if you look in letter B, it's perceived to be going outward because of how those lines on the top and the bottom are and how they are. In letter C, because the lines on the top and the bottom are different, we see that line now as perceiving it as inward. So in letter A, the line on the left looks shorter than the line on the right, even though they are the exact same. Depending on how the lines are at the top and the bottom can either make it look like it's jutting outward, like the outside of a building or the outside of a room, versus the lines at the bottom and the top on letter C looks like it is going inward, like the corner of a room. In figure 7, we call this the devil's tuning fork. It looks like it has two prongs, or it looks like, it has three prongs. But does it have a three or does it only have two? Because if you look at the outside, right? Here we go around the outside. We only have two. But wait, how do we get this third one then? Where did that third one come from? See how this, your mind, your eyes are kind of playing tricks on you. It doesn't make sense. You can't figure out how you see those three whenever you look at the outside and it appears that you should only have two. So that is one of those illusions also. Now, the last thing that I want to talk about in this module is subliminal perception. Subliminal perception is when you are perceiving messages when we don't have any awareness of them. It's subliminal. It's below your level of consciousness, right? That's what subliminal is. The perception of messages about which we have no answers. The stimulus could be a written word, it could be a sound, or it could be a smell. So you have this perception of it, but it's below your level of awareness. That's subliminal perception. So in some studies, people are briefly exposed to a descriptive label called a prime that then later they do not remember, but nevertheless, they can apply it in forming an impression. There is very little evidence out there in the research world in psychology that subliminal messages can change our attitudes or behavior in substantial ways. A lot of people like to think that it does, right? These subliminal messages, like what they do in advertising or marketing, that can change your behavior or change your opinion about something. But there is very little evidence actually showing that. So along with subliminal perception, we have what is called extrasensory perception, or ESP. Extrasensory perception, or ESP. This is where you have perception that does not involve your senses. It is extrasensory, right? So it does not involve your sense of smell or taste or vision or touch or hearing. It is outside of those senses. As psychologists, we reject the existence of ESP. So there is no sound documentation of ESP actually being real and factual. There is a debate in a journal that we have, Psychological Bulletin, that suggests reliable evidence existed for an anomalous process of information transfer, or PSI, process of information transfer. However, ultimately, the conclusion was highly discredited. And I think the reason why we do not believe in ESP is because you cannot prove it. You cannot put the scientific method. Remember optic R? You cannot put the scientific method to ESP. And when people have tried to do that, they could not do it. And remember, the scientific method proves that something is a science. So I'm not saying that ESP doesn't exist, but it's definitely not a science and it's definitely not factual. Okay, that is chapter 4 on sensation and perception.